Okay, so topic for this video is going to be inverse trigonometry, where we are going to be using the inverse trigonometric ratios to find out missing angles in triangles. So, little recap before we get started here. It says, recall that trigonometric ratios are used to calculate the lengths of sides or the measures of angles. That's going to be the relevant one here for today. And a little recap to start things off. Sine. Sine is always opposite divided by hypotenuse. So what that would look like if we got a little triangle here, and that's our angle, that's theta. Remember, that is O, that is H, that is A. Sine is O over H. So that would be this over this. Cosine is adjacent over hypotenuse. So if we had a little triangle, that's our theta, O, H, and A. Cosine is A over H. So that would be these two sides. And tangent is opposite divided by adjacent. So if this is our right triangle, we've got our O, H, and A. Tangent is O over A. So that would be those two. So as long as we can remember which trig ratio to be using for these different such scenarios, we're gonna be flying through this here today. So example 1, solve for x using the correct trig ratio. Okay, so check this out. This time our x is the angle, right? That's the twist for today. We were trying to find the angle. Well, we still start off the same way. Draw your arrows from the starting angle, that's your opposite. Draw your arrow from the right angle, that is your hypotenuse. The last side is the adjacent side. Now we're going to take a look at which two sides we are using. So in this case, I notice that I've got the O and the H. O and H goes with sine, right? Sine is the one that uses those two sides. So let's write our equation here. Remember, inside those parentheses always goes the angle. This time that's the x. And sine, as I wrote up above, is defined as O over H. So in this case, that's 6 over 12. Now, in the last video, we saw how we could cross-multiply to solve these things, right? We would do something like this, put it over 1, and then cross-multiply. We don't need to do that on this time. If we are going to successfully get x from out of those parentheses, what we are going to need to do is inverse sine. If we do inverse sine of 6 over 12, we will get x. So what is inverse sine? Inverse sine is the inverse function of sine. Normally, with sine, you put the angle into the parentheses, and it is equal to the ratio, right? That's how we set up all these equations. Well, the inverse sine function does the opposite. Instead of putting in the angle and getting out the ratio, we put in the ratio and we get out the angle. There are inverse functions for everything, right? The inverse of addition is subtraction, inverse of multiplication is division, inverse of squaring something is square rooting something, right? There are inverse functions for just about anything. This is no different. This is the inverse sine function. Instead of putting in the angle, getting out the ratio, we put in the ratio, we get out the angle. And so all we have to do here is just literally type that into your calculator. In your calculator, next to wherever sine, cosine, tangent is, there should be inverse sine, inverse cosine, inverse tangent. I'm just literally typing in inverse sine of 6 over 12, put 6 over 12 in those parentheses, and it is telling me that x is 30. That is a 30-degree angle in there, which should make sense. That is a 30, 60, 90 triangle there. Remember, the short leg is always half the hypotenuse. So x is 30. Let's try it again here. You're going to see that these ones go pretty quickly here. We start at the angle. We draw the arrow. That is our O. This is our H. This is our A. I notice on this one that my two sides are O and A. And I know that O and A go with tangent. Tangent is the one that is O over A. So I set up my equation. Angle goes inside the parentheses, so that's my x, and this is O over A, that is 50 over 50. So to get x out from those parentheses, I'm going to switch over to inverse tangent. I'm going to put in the ratio, and I'm going to get out the angle that I want. So this time I'm going to type in my calculator inverse tangent of 50 over 50. And who would have thought? I'm going to get 45. Because that's a 45, 45, 90 triangle, right? That is an isosceles right triangle, which only occurs when it's a 45, 45, 90. So x is 45. All right, let's go to the inside and keep rolling here. These ones are going to go fast. All right, draw my arrow. Figuring out which sides I'm using here. This time it looks like I've got A and H. A and H is cosine. Cosine is A over H. So cosine parentheses equals ratio. Inside the parentheses goes our angle. That's the x. And I'm doing 10 over 12. I want to get the x out from those parentheses, so I need to switch to inverse cosine of 10 over 12 to be equal to x. And that's what I'm going to type in here. Pull up my calculator, type in inverse cosine of 10 over 12. Putting in the ratio to get out the angle using the inverse function. And I am getting 33.6 if I round to the nearest tenth. Example 4 here. Let's keep it going. Drawing those arrows. This time looks like I'm using O and H. I know O and H is my sine function. So sine parentheses equals ratio. Inside those parentheses, I'm going to put the x. That's my angle. My ratio is 13 over 25. And so now that I know that ratio, I'm going to switch it into the inverse function to put in the ratio to get out the angle. Okay, inverse sine of 13 over 25. Let's see here. I'm getting 31.3. So that angle is 31.3 degrees. Cool. And let's check this one out. Oops. Drawing some arrows, O, H, and A. This one's O and A. That should be a tangent. Tangent's my function that uses O and A. So tangent parentheses equals ratio. Inside those parentheses goes the angle. This is 8 over 16. Switch it to the inverse function to plug in the ratio so that I can get the angle. And I'm typing it in the calculator here. Inverse tangent of 8 over 16. It's giving me 26.6. Okay, let's go to the top of the next part. All right, solve for x using the the correct trig ratio, same deal. That's my O, that's my H, that's my A. This one looks like a cosine to me. We got A and H. So, oops, sorry. A and H here, cosine. Write our equation. X goes inside, that's the angle. Cosine is A over H, so 30 over 34. Switch it to the inverse function so I can plug in the ratio to get the angle. And I'm typing it in. Inverse cosine of 30 over 34 gives me 28.1. Alrighty, last one here. Now, this one's a little bit of a doozy. This is solve for x, y, and z, round to the nearest tenth. Okay, so I've got two angles to find, and I've got a side to find. Notice the side there is the hypotenuse. So let's just go in order. I'm just going to find x first. So I'm going to start at x. I'm going to draw my arrows. That becomes my opposite. Z is my hypotenuse, and 9 is my adjacent. So the two sides that I have are O and A. Now, O and A tell me to use tangent. Tangent is O over A. So let's write it out. Tangent, parentheses equals ratio. Inside the parentheses always goes my angle. And this is O over A, 12 over 9. So if I want x, I'm going to switch to inverse tangent, plug in the 12 over 9, because I know that should spit out the angle for me. So let me type that in right now. Inverse tangent of 12 over 9 gives me 53.1. Okay, so part 1 done. I use those sides to get my x. Now for y, if x is 53.1, then I can use the triangle sum theorem to add up the 53.1 and the 90, get 143.1, subtract that from 180 to get 37.9. So y should be 37.9. All because there's got to be 180 degrees inside every single triangle. Now, lastly, for z, I'm going to do the Pythagorean theorem. A squared plus b squared equals c squared. If I know two sides of a right triangle and I want to know the third one, I always go back to the Pythagorean theorem. This should be 9 squared plus 12 squared equals z squared. 9 squared is 81, 12 squared is 144. That's all equal to z squared. 81 and 144 is 225. I don't know why I wrote 222. 225 is equal to z squared. Sorry, my z's look like 2, so I put the little line through it. And then I take the square root. Take the square root of that, and I should get that z is 15. And there you have it. We had to do a little inverse trig, we had to do a little triangle sum theorem, and we had to do a little Pythagorean theorem. 3 great things. All right, so inverse trig, really, really not bad. Just figure out which ratio to do, and then type it in. Your turn to try. You've got 6 to give a shot on over here. All of them are just solving for x, none like that last one we did, but give them a shot and then come back when you're ready to check to see how you did. All right, so number 1, this should have been a cosine one. Cosine of x is equal to 20 over 24. And if you did inverse cosine, let me see what you should have gotten. Inverse cosine of 20 over 24 is 33.6. This one should have been a tangent one. Tangent of x is equal to 8 over 5. So you do a little inverse tangent of 8 over 5. And you should have gotten 57.99 or 58. For number 3, that's another tangent. Tangent of x is equal to 20 over 30. So changing that should give you 33.7. For number 4, that should have been a sine. Should have been sine of x is equal to 40 over 85. Over 85 gives me 28.1. Number 5 should have been a cosine. Cosine of x is equal to 36 over 50. That gives me 43.9. And lastly, number 6 should have been a sine. Sine of x equals 18 over 30. So we do a little inverse sine to end this one off. And 18 over 30, if you got that one right, should have been 36.9. And that'll do it. Pretty quick one there. Hopefully that went well.